Well, let's look outside. I've had a couple of people ask how things work on my shed. And the first part is I decided I would have a sliding door rather than one that opens, because they take up space either inside or outside. So this one just slides. And the way it's done is very simple actually. At the top here, you can see there are two 2x2 by 5mm angles. One side has been ground down so that it's only an inch, and you can see the bolts holding it apart, and they space it out so the gap down the centre is consistent, and the inner side has been drilled and countersunk to take screws, and the outer one has been drilled so you can get a screwdriver in there, and then that goes all the way along. And sitting on the top of the door are some bolts which go through, and they go into a housing which you can see here, and that has four bearings on it, one on each corner. There are two of those, one at the front, one at the rear, and the whole thing slides in and out on that. And it slides quite smoothly. And at the bottom of the door is this metal plate, and there's a hook on there, and that drops down over the metal strip, and that means it can't be pulled outwards at the bottom. So that's how the door works. And if we come down from the door, you see in the bottom there is a load of gravel. Now there's a soakaway all the way around the workshop. It goes down to the depth of the base foundation and is then infilled with gravel, so that when we get heavy rain, it comes down the path, it drops into the gravel and then just soaks through into the earth. The back is slightly different, but that takes the fall of the roof to the back, and that has got, and this is the back, and you see the guttering runs all the way along here and down in some pipe work, and that drops into a water butt, which is one of a number of water butts linked together. Just down here is an extractor vent which sits at the back of where the lathes are, and a later addition is at the end here is a tool locker, which was an add-on a year later for my other half for her gardening tools. But this end, the base of it actually has my compressor in, and that's surrounded by polystyrene, to stop the compressor getting really cold or really hot, but also it helps soundproof. So that's basically the outside of Dad's shed. Now we'll go inside and look at the current project. Well, welcome back to the inside of Dad's shed. In the last video I did, I produced the new parts to improve the tool post on my main lathe. And you may recall it involved manufacturing a new T-nut to go in the compound slide, a new holding bolt, a new top nut, and using a thrust washer. The last part of that job was turning the arm for the ball for the handle for the top nut, and that is tapered because it looks much nicer and it doesn't need to be square. So in order to do that, I offset the tailstock. Not my favourite occupation, because having offset it, you need to reset it, and that is the job that I need to do today. So what I've done so far, I've reset this to the centre line that's marked on it by eye, but I know although that's approximately right, it's not going to be accurate enough, because the next job to go in here, I need the centre to centre up the spindle, which is half produced, so that I can put the fixed steady on it. And I want it to make sure it's nice and square, otherwise it will run out automatically. So I need to get this set up. So I'm using a piece of steel from my favourite source, the scrap skip. It's a 26mm bolt. It's a high grade steel, so it works quite nicely for this application. I've turned the hex off already. I've turned that down. There's a small shoulder on there, and this is about 25mm now. So that's going to hold in there. I've turned down, and I've almost completed turning down below the threads. Once I've done that, I'll then measure the two ends of this. And the nice thing is that this bolt is almost exactly the same length as the spindle is. So I know if this is parallel, the spindle will set up parallel on the centre. So what I'm going to do is I'll turn off a little bit more of this to make sure I've got rid of all the threads right down to the core. I'll then measure it with a micrometer, and then I'll set up a dial gauge on the tailstock and move it in whatever direction is needed. Now I have to keep remembering that if I have it 2mm out there, I need to move it 1mm there, because I've been that stupid person who's moved it 2 and wondered why I've got exactly the opposite reading the next time. So that's going to be the next little job to do. So I'm going to set up for that now, and I'll be back with you in just a few minutes. Okay, so we're now set up, ready to do a little bit of turning here. I want to get the right tool, so I want a nice surface finish on this. So this is WMG tool, and I find that cuts quite nicely. The big problem with this is that this steel doesn't chip very well, and it tends to come off in long strips of swarf like this. So let's see, what are we going to set this up at? So, quick look. That's high speed. Let's take that down a bit. I think we'll go down to about 660 RPM. Make sure the tailstock is engaged. Give about a ½ mil depth of cut. I'm not very impressed by that surface finish. I might actually go back to the previous tool. That's not looking good at all. So let's take that one off, put this one back on. that's looking a bit better. You can see what I meant about the swarf coming off in long ribbons. And unfortunately with a 3-jaw chuck, that means it's going to try and bite it and wrap it all round. Well, that surface finish I'm quite happy with. Let's grab a little bit of lubricant for that. Let's change that speed. Now I've been told this is something I can't do. I've just literally gone from high speed setting to low speed setting. I'm going to take this up to 800 RPM, which is the highest of the low speed, from 600, which was the previous one. But I keep being told that I can't, with the inverter setup I have over there. In fact, I've gone the wrong way. Okay, so that's that. Let's give that a quick wipe down. That's quite a nice surface finish considering it's a fairly coarse feed. .889. .887. So it's 2 thou out over that length. Now that's not bad at all. Let's see if we can actually move this across by half a thou. So I'll move that out. Don't want to go any further back from there, so I can actually get to everything. Let's move this across. I'll undo that. Move that across to there. Let it go in a fair amount, and then hit the on and 0. Right, so that's now set up. And I'll come back to this in a second. So because this end is slightly larger, it needs to come towards me. It needs to come towards me by about 3/4 of a thousandth of an inch. That should be about there. If I do that up like that, I would say that's now moved across. Okay, that should hopefully be about right, but there's only one way to find out. So let's take that off, turn that off, save the battery. I might actually change that and put a non-digital indicator on there to see where we are. Put some gloves on and just clear some of this swarf out the way before I do any more. Let's put some cutting paste on there. H845. So I still need to bring that across a little bit. I'm going to hold for a second. I'm going to swap my dial indicator over to something that's a rather more old-fashioned one. So I've done a bit of a swap over here. I've put my batty gauge, nice little buy from Ramco, in here. It's graduated in half a thou, but there's enough space in there to estimate pretty well 3/4 of a thou. It's in the tool post, and I've now lined it up with the centre of the tailstock. So what I'm going to do is try and move this across a little bit. That's the wrong way. That's half. That's 3/4. That's gone to 1. I need to back that off a little bit. Just try to take that straight. Get this to actually fit into the Allen key head. That's fine, that's a bit better. That's nice. Tighten that up a little bit. Now as you tighten that up, that's sitting nicely on 3/4 of a thou. So I'm hopeful that that should give me what I'm after. It's one of those things where sometimes going back to older fashion technology and an analog gauge rather than a digital one actually gives you a rather better result. Because whereas they're both graduated the same, my digital Mitutoyo and this are both graduated in 1/2 thousandth of an inch, but because this is analog you can actually see the spaces in between, and that gauge allows me to give a pretty good estimate of 3/4 of a thousandth of an inch, whereas the digital gauge gives me either 1/2 or 1 thou and nothing in between. So sometimes the old ways actually work a little better than the new. So anyway, that's that done. Let's see where we are. Back on there, nice and tight, that's in tight. So that's the major disadvantage here, is that this metal, although it's really good quality, is not free cutting. 807. So that's made absolutely no difference whatsoever to the taper on that. Let's relax that. Let's just relax this a shade and then retighten that. I think I'll go up to the high speed, and while I've got this loosened off, I'll take this back. And get the swarf off. I think I'll do one more cut down at that setting without changing anything, and seeing if loosening and retightening has actually given any change at all. I've found this a few times when you've been setting up here, is that you make a change at the tailstock and it's a measurable change, but when you get down to this end, the business end, doesn't do anything. So let's go to 3. Let's have another look. Seven 4-0, 740. Oh, that's absolutely spot on. Right, that is dead. Same size there and there. So I'm going to declare myself happy with that little setup. And I'll then start to look at setting up to do the boring of the spindle. So this is using an old bit of steel, turning it down, resetting the tailstock from the taper to parallel, and I've now got a nice parallel 7-inch shaft there. So I know that a 7-inch shaft in there will be set parallel between the chuck and the running centre. So I can use that to set up my fix steady to make sure it's running true, and then I can look at drilling and boring out the spindle, and that will be another video. But before we go, I'll just show you a few of the little things I have done on other machines I've got in here to enhance their capabilities. And the first thing we'll look at, I think, is the myford lathe, which is over there, and a really simple bit of work that was done on that, which has made a huge difference. So we're over at the myford, and I've shown a little bit of this, but I'll show a little bit more. One of the main changes I made to it is that last year, when I had a bit of time, I folded up and fabricated a splashback, and as you can see from the marks down there, it's doing its job. Doesn't manage to stop it getting all over the tool cabinet that's sitting behind it, but it cuts a lot out, and I will add a little bit to the top here. But it's been folded. The fold was done through 2 lengths of 2-inch by 2-inch angle, because obviously the bench vise or a folder is not really big enough for this, and I don't have a full-size folder. So it's folded along there, it's folded along there, and then the end has just been welded in place. Clamps down the side, a couple of clamps on the back, and then in the corner here, that's folded up. That is welded in place. So you've got that sitting along the top there. So that gives me a shelf. And then at this end, a few extra little bits folded over and welded in place to strengthen that end and guard the motor as well. So that took about a day just playing around doing that. As I say, I'm not the greatest welder in the world, but I can manage to stick things together, and I managed to do that. It's painted white because the one thing I have found is that light coloured machine tools, same as light coloured walls, bounce light around rather than absorbing it, and it makes working in the workshop much pleasanter and easier if you can actually see what you're doing. So that reflects light off the overhead lamps so that you light around the tool post quite well. So that's the little change I've made to the myford. It fits in quite nicely, I think, with the overall feel of the machine, and it does a good job. So a few other little adaptations or tools I've made, which I will show in future videos, but for the moment I hope you've enjoyed the short visit to Dad's shed.